Okay, so here we are. I have my little Nvidia Nano right here. And then I actually just purchased something, which is this USB speaker. And so the idea that I'm going to be having is I'm going to be connecting this to my Nvidia. And from that, I should be able to to talk to my device, right? And I'll need to be able to capture that voice, transcribe it into words, into like characters or tokens, translate it into words, and then translate it into tokens, and then from that put it into my AI model. So I'm gonna open this up, see what we even have in here. But yeah, let's check it out. Okay. Ha! Ah, okay, so the instructions, yep. And now we have USB to USB-C there. And then we have our little puck. Okay, so yeah, today's goal is going to be, let's open this, right? Okay, so that's what it looks like. Let me make myself a little bit bigger. You can see what it looks like. There we go. So this is what it looks like right there. Can't really see the words on it, but whatever. So that's what it looks like. Now, I guess the next step is try to figure out how to get Whisper on this, how to be able to transcribe our words over. Okay, so let's first plug it in and see what happens. I have my Nano connected through SSH here, and we will see if this comes alive. Where is okay? So there's the USB-C connection, and then we have our USB, our normal USB. Okay. There's a lot of wires going on now. Okay, so let's plug this in. Hopefully, I don't know if it needs special drivers, but hopefully it does not. Okay. Woo. Okay. Interesting. So we got that. I wonder. I see a power button. Let's try it.
Movie mode.
Movie mode. I don't want movie mode.
Music mode.
I don't want music mode.
Movie mode.
I don't want movie mode. Okay, hold up a second. Maybe we want music. I don't know. Sound effect. Short press music. Movie. Okay. Play pause is clicking the knob. Okay. Ah. Okay, that doesn't. I don't understand what's going on here. Um, volume up down is rolled knob. Would it? The knob also seems a little off kilter. Anyways, charging EQ mode. Sound and pause button. Okay. Alright, plug it into the computer, USB port. Click sound icon in the taskbar. Ah, we don't have a taskbar, do we? Expand output, choose USB as the sound device. Okay, so the first thing is I think that this is like this button is not really like I can do that, but if it comes here, it's like depressed down and it's off kilter. So is it broken? That's why I was like, what's going on here? Okay. I think it's broken. That's annoying. Okay. But now, how do I, actually let's, go to here and see if we're able to figure out how to get this to actually connect. Okay. I have an Ubuntu system, which is on my Nvidia device. I am using an Nvidia or a Nano, period. I have just purchased a USB PC speaker, and I plugged in the USB from the speaker to my Nano. And now I am trying to figure out how to actually be able to record sounds, period. My ultimate goal is I want to be able to record my voice and transcribe my voice into words that I can then feed to an LLM, period. What other important context do I need to give it? I don't know. I don't know. It'll be fine. Oh, I should have said that it was running headless. Open your terminal. Okay, so ARE chord. Okay. So ARE chord minus L. Whew, interesting. Okay. So, what is this? Tegra, D-Link, subdevices, okay. All of the different devices. I'm not sure exactly what devices these are though. Nano Ape, like X bar, I don't know. USB audio. Okay, I think I see it right there. Okay. USB audio. Yep. If you see it listed as card 1, you're ready to test a recording. Okay, so record for 5 seconds to test. Okay. Turn on your voice into words for an okay. First off, what is this command? Question mark. And what is all of the information which I'm seeing? Question mark. I do see this line of what does it mean and what are the other things which I am seeing? Question mark. So I'm guessing that this is just going to mean that like it's there, but I want to make sure. Okay. Anyways, question number 2 is for this. Can you go over everything in this command and tell me what is happening? Question mark. I don't know what the command does, any of the flags do, any of the arguments, period. Explain it in full, period. Okay. So now if we want to actually take our voice and put it into an LLM transcription, yeah, so I think we're going to be using Whisper, which is actually what I'm using right here, right? But this one is towards the company. The Whisper that we're going to be using is um, like either Fast Whisper or Whisper. Okay. Heavy on RAM. Ooh, I don't like that. Okay, so number 3 is going to be my Nvidia Nano has very little RAM, and so I need to be extremely cautious of this, period. My goal is to be able to speak in English or Chinese to the system, period. Okay. So I intend on using some form of whisper, comma, but I don't know the exact details of what I should use for it, period. No, we're not doing this. Okay, so the workflow. Once the hardware is recording, your Python script will follow this flow. Okay, so we're going to capture using speech recognition or Pi audio to listen to the mic. Transcribe. Pass the audio buffer to Whisper or Rivera. Okay. So I think that that would mean that we do it from the actual. Let me get this off. I think that that would mean that we do it from the actual, like from within our Python script. What I mean by that specifically is like from here, right? So here's all of our. I think actually I'm gonna take this and move it into a different folder. Right now we're in this like examples, but I might take this out and start working on the actual project. Um, but we have this infinite while loop right here. And within this, I'm looking for user input just as like they type it. And so what I'm thinking with this is instead of typing it and getting it as user input here, or actually here, but instead of doing it this way, I will do it from the voice and I'll need to do the transcription in this part and then I keep this kind of the same. Okay, so take the resulting string and wrap it in a prompt. Yeah, okay. So we don't care about that actually, because we already did this. And we're going to use our special prompts and stuff like that. Send that prompt to the LLM. That's great. Okay, cool. We already got that. And OpenAI Whisper. Okay, so, but there are multiple. Okay, so I'm seeing multiple things for Whisper. And then I saw that you also told me to get Pi Audio and OpenAI Whisper, period. What are all of these different things and what do I need and why? Question mark. Setting up a swap file if you haven't already. This gives the system extra breathing room. I thought swap files were bad. Okay. I thought that swap files were bad because doesn't that mean that I am taking the memory which is in my RAM and moving it into the SD card and that has huge amounts of latency? Question mark. Okay, so let's ask our follow-up questions and see what we can get. Okay. You have much more powerful machine than the original Nano, but the RAM management is still, yeah, no. I shouldn't have said that because I don't want it to be like, oh, you have more RAM. Okay, so this A record. There we are. Is a command line recorder for the advanced Linux sound architecture. Okay. So card X. This is the physical or logical sound card. Card X. I think they're referring to a specific. Let's look. Card X. Do you see anything that says card X? I don't. List of capture hardware devices. I'm seeing hardware devices. Like, I know the list, obviously, but card X. Oh. Card, like, and then X is a placeholder. Man. Okay, I'm sorry. Card 1, card 2, card 3. There we go. Okay. This is the physical or logical sound card. Okay. Device Y specifies or a specific input output path on that card. What does that mean? Okay. These are internal audio processing engine paths. They handle HDMI audio or I2C headers. You generally won't use them. Okay. Card 2, this is your winner. Yes. This is your USB device. To address this specifically in a command, you would use hardware 2. Okay. So I have a bunch of follow-up questions. So, what do you mean input and output path? Question mark. Can you give me an example using the USB audio card which we found? Question mark. I'm not only trying to get this to work, comma, but I also want to be able to understand the concepts and learn as I do this project, period. Okay. Question number 2 is it's giving me this specific thing here, right? And I know obviously card 2 device 0, but I want to know, like, let's pretend we didn't have AI and I see card 2 here, but I see this P10S, okay, device 0, like, oh, sub device. There's so much going on. How would I have known this, right? Um, how did you come up with this? Question mark. And can you go through each of the items within the USB audio line, which was the result of the A record command, and explain what it means, period? Because I'm seeing so many different things, such as P10S, device 0, subdevice 1/1, subdevice hashtag 0 colon subdevice hashtag 0, but I don't know what it actually means, period. Okay. All right, breaking down the command. So, A record. Wait, hold on. Is this the same one that we did? This one was. Okay, so we're doing to the same executable essentially, but then we're doing like this one was list. This one is. Okay. Device flag. It tells the computer exactly which hardware to use based on your output. You should actually change this to hardware 20. Okay. Interesting. Okay. I think we are on 3. Which means here. This is bugging me that it's broken. I don't I wish that I could. pull it back up or something. I don't know if it's definitely broken. Like, I don't know if you guys can hear. It's definitely broken, but I'm just like, I want to be able to fix it, and it's bothering me that it's broken. Okay. So the base program to capture audio. Okay, yeah, this is like the executable, right, that we're running. And then device flag. Can you tell me more about device flags? Question mark. What do they do, comma, what are they, comma, what are some other instances and examples of when I would use a device flag? Question mark. Teach me the concept of what a device flag is and how it is used and what I need to do with it. Whatever. You know, it'll know what I'm asking. And so I can understand that this right here means that we're using this hardware device. Okay, but I want to be able to really like understand what is that doing, because like okay, I can understand it when I look at it, I can read it, I understand it, I can put it into the computer. It goes. Congratulations, it works. Right? But why? And by the way, like if I just came up here and said not said that, said oh okay, it told me to do this, right? And copy, paste, right? Well, then it wouldn't have even worked because we were talking to this device, like device 0. Oh, wait, sorry, device 1, card 1, device 0. That would be what, this one? Card 1, device 0. So whatever this thing is, right? Like Nvidia Orin Nano Ape. Okay. Yeah, we would be trying to talk to that instead, and that wouldn't have even made any sense. So that's why I like to investigate things and make sure that I really understand everything. All right, so the duration. I thought that the D was gonna be like a daemon to like background thing. For exactly 5 seconds, and then stop automatically. Format. CD is make sure. Nope, 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 nope. Go away. Okay. That is a bad word to be saying around here. These two letters. Okay. Every time I say this, the little Apple Assistant decides that it is going to wake up. It says, "You called my name?" And there was one time I said that letter and then the other letter. And you know, like I was doing it like LS, right? And then I did this. And obviously you now need to go into a path, right? And I was asking, okay, so where am I? Well, the little Apple Assistant decided to be very helpful while I was recording a video, by the way. The Apple Assistant decided to be very helpful and give my exact GPS locations. Thank you. 我谢谢你. Okay. Okay. Well, so that's why every time I say those two letters, I have to say this letter and then say something else and then the other letter. Okay, so if we say those two letters together, it is short for compact disc. So it's not. I was thinking that it was going to change into a directory. Okay, 16-bit little Indian, and we are at 44,000 hertz. Okay, and we're going to save it into this file name. Awesome. So because you need English and Chinese and have limited RAM, standard OpenAI Whisper is not for you. It's written in Python and is a memory hog. Okay, so we're probably going to have to use the C++. Instead, use Whisper.cpp. It is a high performance rewritten in C++. So it uses incredibly little RAM. Okay, and is optimized for ARM processors. Awesome. So not x86. So we are good. You should use base or small multilingual model. Okay. Tiny is too inaccurate. For Chinese and medium will likely crash your RAM. Okay. So, PyAudio, a Python library that connects your code to the microphone. Okay. Do you need it? Yes. If you want to write a Python script that listens in real time. The original Python version, no, it's too heavy. Okay. So, yes, we do need the CPP version. Version optimized using C translate. Okay, alternative. Faster than original, but is usually leaner. And by leaner, I'm guessing that they mean less RAM. So let's just do this Whisper CPP. So let's do the whisper.cpp method and use the PyAudio. Period. How would you suggest me getting those two things onto my Nano? Period. I am currently SSH'd into it and my device is headless. Period. I'm hoping that the PyAudio is going to be a really like sudo apt install kind of thing. This one I'm hoping I might need to go to like the GitHub repo and clone it down. I don't know. The swap files. Swap is significantly. Oh, the other thing that I got is I didn't open it yet, but oh, make sure that that didn't. Um. Anyways, um. So the other thing that I bought was I was the my information was on the other side, and I was like, oh, hopefully I didn't show. Anyways, okay, so we're good. It was just a barcode. That's why I was like, oh, wait, hold up. But then it was on the other side. So about that, that is RAM right there. Not RAM, sorry. That is an SD, like an NVMe SD card, which is going to go on the back. So not RAM. I wish I had more RAM. I really wish I had more RAM, but I don't. So, actually, technically, I kind of do. Technically, I kind of do. If you guys want to see something cool. Ah. Technically, I do have more RAM. But, oh, this is really heavy though. Okay. Oh, there we go. But, I'm meaning I don't have more RAM. And I forget what that one is. I think it might also be an Orin. I don't know. Anyways, we're talking about the Nano though. We are talking about the Nano. So let's look at the Nano. Where's it going with all of this? Okay. Especially on SD card, yeah. However, here's the why latency versus crashing. If a program like an LLM uses 5 gigabytes of RAM and you only have 4 gigabytes, Linux will immediately kill the program to save the system. This is an out of memory error. Okay. I thought it was a stack. No, a stack overflow is when one process exceeds the maximum allowable like memory usage allocated by that by the okay, let's do that one. You mentioned that if we only have 5 gigabytes of RAM, I said 4 gigabytes, and we ask for 5 gigabytes of RAM, Linux will immediately kill the program to save the system, and you called this an out of memory error, period. But I'm trying to now understand what the difference is between this and a Stack Overflow, period. I remember Stack Overflow being something about a process asking for more memory than was allocated when it started up, but I'm not sure who allocates the memory, how it's allocated, and if we have dynamic memory, wouldn't that mean that we can keep going until we run out of physical RAM? But that situation seems very similar to this, which you just called an out of memory error, period. Also, does it only apply to threads? Other way around, to processes? Or I remember when I was doing something in either C or C sharp, I had to allocate a special. No, what did I need to do? I'm recalling, like, I remember doing this in a project, and I needed to like say exactly how much memory to allocate to do setup operations before I actually started a thread. And one of those operations was to explicitly set the size of this thread, period. Can you explain how this is integrated into these concepts as well? Question mark. And show me the C code, period. I think it was C. C sharp is like you would have to do a whole bunch of like unsafe. By unsafe, I mean literally call it unsafe. So it wasn't C sharp. It was C. Okay. All right. So the safety net. A swap file acts as a spillover tank. If you run out of RAM, the system moves state or stale data, stuff not being used right this second, to the SD card. It's slow, but it keeps the program from crashing. I haven't experienced any crash, but if you use an NVMe SSD with your Orin, yep, we bought that. The swap speed is actually quite decent. Okay, so what are we even on? This is 5, so now we're on 6. What does it mean when you were talking about a swap file, and how would I actually accomplish this? Question mark. Give me the concepts to this, period. How would you suggest I actually go about putting an NVMe SSD into my device? Question mark. And transferring over all of the operating system and files and all of this, because I've already been working a little bit on my micro SD card, period. All right. I'm actually curious, like, if I just speak in Chinese, will this pick it up? 那我其实想试一试，我说中文的时候，你可以明白我的意思吗？还是你会有点迷惑？Okay, I was not expecting that. Dude, it just translated it. Okay. What? I was expecting the Chinese, like actual the Chinese characters. I was not expecting it to translate it into English. That was not expected. Okay. I also don't know if that is quite desired. Because if I'm speaking to it, obviously I know that this whisper is a little bit different than the other whisper, but if I'm speaking to this, broken. If I'm speaking to this, I want it to be in like actual Chinese, not translated into English. Since you are working here, you're in industrial grade embedded system computer. Okay, decoding here. Think of your computer as a giant office building. Okay, so card 2 is the floor number. Device 0 is the specific room on that floor. Subdevice 0, the specific desk in that room. Okay. So on my Nano, there's a whole bunch of like cards, right? And then the device, this is a device, but then within this device there can be multiple sub devices which would be there. Okay. So card 2 and then P10S. So this is the short name or ID of the hardware chip inside of the USB speaker. Oh, okay. Device 0, digital stream. Most USB consumer devices only have one device, 0. High-end audio inferences might have device 0. Okay. Subdevice 1 of 1. This means the hardware is capable of simultaneous stream, and the 1 is currently available. If you're recording, it would have shown you 0, 1. Okay. In Linux, sound is bidirectional. A record looks at capture input paths. A play looks at playback output paths. Even though it's one USB plug, the operating system treats the recording side and speaker side as two different logical paths. Okay. Device flag is a command line argument that modifies how a program behaves. Yeah, okay, that's the D flag stands for device. Tells the software don't use the default system microphone, go specifically to the hardware address. Okay. The rate flag tells the mic to sample at 16,000 hertz. Okay. C1 tells it to record in mono instead of stereo. Okay. Sudo apt install build essential. We already have git. We already have pip. Okay. And we do need to clone this. Okay. I don't know what I don't have. Let's just update. Okay. Jetson. All right. So while that's doing its thing, I'm just gonna copy and paste this. I'm not gonna type any of that out. Okay. There we go. Hopefully, it will just be fine. Oh, actually, I didn't need git. Oh wait, yes I did, because I'm gonna be doing that. So never mind. Okay, so then we're gonna clone. We're gonna go into it and then make it. Okay. Hopefully this one's just a pip. Oh, this is a pip install. Okay. Alright, so now I want to say pwd and Yeah, so from here, where do I actually want it? Do I want it inside of my agentic AI or do I want it outside of it? Let's just do it outside for now. Okay. And then pip install. Okay. While that's doing its thing, we will I remember pip install pip is different than apt because it is not system wide, period. How will this affect my Python code and where I need to actually run this pip install command, question mark. Okay. So okay, so out of memory is this is a system level failure. The RAM, the physical RAM and the swap are 100% full. Linux picks a process, usually the one using the most RAM, and kills it to prevent the entire OS from freezing. Okay, I see. Stack Overflow, this is a process level failure. When a thread starts, it's given a small fixed stack, okay? 8 megabytes on Linux. If you have an infinite recursion or a massive local variable, you hit the ceiling of this allocated space. The program crashes with a segmentation fault. Okay. Even if you have 32 gigs of RAM free. Okay, so pthread adder. Yeah, I remember doing this. Set stack attribute. Yep, here it is. Here it is. So in let's see. So like normally it's 8 megabytes, and now we're doing like one right here. So that way we're just saying like, hey, this thread, it's not that big. Don't allocate too much memory to it. Which is actually very similar to what I was doing previously. Just like downgrading the memory from the default. In this code, the OS allocates the memory for the thread stack. If you use malloc, you're using heap, yeah, and you can grow it until you hit the I see. Okay, so I see. So this one only applies literally to the stack. It's not the actual entire thing of that thread. I thought that it was like just the OS kept track of just the entire. Oh, this thread can't use more. Solve files designated is a designated file on your storage that the OS pretends is RAM. Okay. chmod. We might do this later. I don't want to do it right now because I don't have the SSD. Okay, so how would we do the SSD? Moving from SD to SSD. It is able to increase the speed by about 10%. Provided Jetson container scripts to flash the OS onto it. Okay, great. You can actually keep the bootloader on the Yeah, that makes sense. And use the SSD as the root file system. Awesome. Okay. Video provides a script here via their. Awesome. Okay. Is it still going? Man. Once I have built the whisper which you told me to get from GitHub, comma, how should I set up my Python code to be able to utilize everything? Question mark. Give me an example, period. Okay, and we just finished, so you can use it like this. Awesome. Pip is Python package manager. If we run this, you might overwrite a Python library. Solution, use a virtual environment. I don't want to use a virtual environment, actually. When you run, it stays inside that file. Okay. So, since this is written in C++, I hope we don't have to do what are they, like bounces or something like that. In C sharp, you have to do p invoke. I think with C++, there was something like bounce files or something. Instead of loading the entire C++ library into Python's memory, which is heavy, your Python script will record a small file and hand it off to the high-speed C++ binary. Okay, so the buffer and fire method. Python uses PyAudio to listen to the USB mic. Okay. PyAudio to listen to. Yep. Detects a pause in your voice and saves a tiny wave file. Calls. Okay, that actually makes a lot of sense. All right. So instead of this, what we're actually gonna do now is I'm gonna come here, right? And where do I want to start writing this? Because we're gonna we're gonna write it here in our IDE and then just copy and paste it over. See if it works. So what I want to do is, do I want to example agents, or maybe I can say example and then a sound recording, sure, whatever. Then within this we have a new one, example 1.py. Okay, like this. So now what we want to do is come in here and say this. Okay, import Py audio, import wave. All right, import is Copilot on. OS. No more imports. Okay, so format is going to be equal to Py audio int 16. Okay, that's fine for now, whatever. Channels is equal to 1. Rate is equal to that 16,000 kilohertz, which we saw. There we go. Okay, chunks, singular. 24. Okay, so that's probably the size of each chunk of like audio, like essentially at the How many bytes? So wave output, right, is equal to whatever this input dot wave. We'll have to change all of this stuff. So now we need to actually put the real path to this. Whisper underscore path, okay, is equal to. Now I need to come here and I need to say, come on. Well, it's a little bit frozen right now, but okay, it's a lot bit frozen right now. Home Timothy desktop. There we go. All right, so ls and change directory into, where are we? Oh, desktop whisper, okay. And where is the, so we're looking for whisper, here it is, whisper.cpp, right? Now we want this binary, so we want models here, okay. Okay. And make sure that we have this thing, ggml. Okay. Base binary. Okay. That's for test. Here. Right there. Okay. So I think we should be able to do something like this. And then the ggml base.bin. Okay. Now model path. Oh, they want it to main. Hold on. Whisper path, model path. Okay. So instead of whisper.cpp, is there a main? CC make. I don't see a. Okay. Does this mean I need to do and then I also like to ask dumb questions, right? Because normally when you're doing projects, you get to like stumble upon a bunch of dumb questions, or basic questions, and it's a good opportunity for you to cover them up. Not cover them up like hide them, but I mean just like cover up the hole because you fill it in, right? when I am doing a path, comma, am I able to use the tilde to go from my home to the location, comma, and then I can also do it from the absolute path, which is the slash. Do both absolute slash methods work, question mark? Right, because when we do the little tilde, I think that's from the home. But then you can do the slash, which means like the full path. It's like this. Users, Timothy Grant, desktop. Or, like, it would normally just be like desktop practice agentic AI. Okay. So now the second question that I have, or third question that I have is question number 3. I'm going to come here and say I am not seeing anything which is main, period. All right. So let's assume that it's going to work, right? So we can just come up here. Whoops. It's equal to what? This here, whisper CPP, and then main. Okay. So now I want a function record my audio here, right? And now what I'm going to be doing is grabbing the audio and then trying to actually, yeah, so grabbing the audio from that thing. So like audio is equal to this pi audio dot and then here. Okay, so we're calling it. Now we get a stream. It's equal to this audio object open, and now we can pass in all of these things. So format is equal to format, okay. Channels is equal to channels, okay. Rate is equal to rate. Input is equal to true. Input device index. I don't know what this one is doing, but fine. And then frames per buffer is going to be, okay, so, oops. Okay, so chunk, all right. Okay, so print, and then just listening. Frames is going to be an empty list. Okay, so come on. Except, here we go. Do we need like the error or whatever? Fine. Keyboard interrupt here, and then finishing. Okay. So okay, so for this one, while true, we're just gonna keep going. Data is equal to stream dot read chunk. Okay. Frames is equal to append data. That's all we need. All right. Um, so with wave dot open, wave output, and whatever as set in channels. We're gonna have to figure out what all of this means later, but we'll do that as I just said. Sample width, okay. Audio dot get sample size format. Frame rate is rate write frames is okay, nope, but a byte array, right? Dot join. Okay, so I don't know what was happening here. With wave.open here, set in channels, set width. We're joining on on empty, so we're joining these frames together. Okay. So stream dot stop stream dot close. Okay. Audio dot terminate. Awesome. Okay, so now I want transcribe, right? So here's where we call the C++ binary directly. Okay. Sure, I'll write these comments as well. Oops. So int, no time stamp. Okay. This one is going to be OTXT is output just the text. Okay. Command is equal to, nope, this one. Whisper path minus M. Okay. Model path. Wave output. There's a lot of magic things going on right now, but hopefully we will figure them out later. Int. There we go. Result. Is now equal to sub process dot run. Okay. Nope. Sub is that a real thing? SUB process. Do we? not import that, or what? I guess we did not. Awesome. Port sub process. Okay. There we are. All right. Capture output is true. Text is equal to true. Return result dot standard out. Dunder name is equal to dunder main. Then we record the audio and we get the text, transcribe, and then we print printf. You said okay. All right, there we go. So now RAM safety is use base or small. The tiny model is great for English, but will struggle with Chinese characters. Okay, so good. Hopefully it does actually do Chinese characters. Headless advantage, since you're make sure that the Ubuntu GUI is turned off. Yes, we already did this. Swap file, that's fine. That's whatever. Creative. I'm not gonna do that right now, actually. Okay. What is it? 1, I think 2, 3, 4. How does it look? There we go. All right. Let's see what it says, and then hopefully we'll be able to get some speech going on. And then I want to do it the opposite way as well. So I want to be able to do speech and then flip it around to be able to talk back to me, but that's gonna be later. Right as okay, whatever. You realize the terminal You realize that what the terminal understands is slightly different from what Python understands. See, this is why, like, even though I was a little bit like embarrassed to even ask that question, it was, if you're not willing to kind of like swallow your pride and ask those really like questions that you should already know the answer to, well, then you're just going to continue in your ignorance. And it's much better to just like, okay, well, let's figure it out, and then you don't have that problem next time. Or actually, quite honestly, sometimes I have the problem 2 times or 3 times or 4 times or 5 times, right? But if you consistently like don't ignore those, eventually they go away because you do it. If you do it after 5 times, right, now you're going to be able to understand it. So, anyways, and I told it, get this. There's a lot of just clutter around here. Like the Nvidia is here, the puck is here. There's wires all over the place, and that button is broken. It's all sorts of debauchery. There's the instruction manual here. It's like, oh, to be clean, but it's okay. Anyways, the model path, the tilde. In your ls output, you confirmed this exists inside of here. The catch: in your Python script, you cannot use the tilde, okay, directly inside a string like here. Why? The tilde is a shell shortcut. Oh, I thought that it was a like Linux recognized absolute path essentially, and that you had 2 like starting points. One was with the slash, one was from the tilde, but apparently that is incorrect. Once again, very good that I asked it. Sees it as literal character named tilde, not as the home directory. Okay, absolute path. All right. So if I come here, this, so I should be doing this, right? Okay. Actually, I just want, because I already put tilde desktop, so I'm just gonna do this. Yeah. I got a little bit confused because like Timothy, I thought I was expecting like Jetson, but Jetson is the name of the. Okay, anyways, doesn't matter. Relative path. It's not in the correct folder or not in the same folder. Use absolute path. Awesome. If you don't see this, it means the compilation step hasn't finished. Or is moved output. Recent updates renamed to Whisper CLI. Please have Whisper CLI. Oh. No. I see CI. Oh, man. Okay, so let's just see if we can find it. Because we already built it. We did the make file, right? Um okay, so I'm gonna say I didn't run the make J2 command, which you told me, because in the previous command, I already did the make, period. But when I do the search, this is the output, period. What does this describe? Like that. There we go. OS. Use OS. Actually works. I don't want that. OAuth pat. Okay, so we're just doing that in the main. That's fine. That's whatever. All of that seems. There's some things that are different. Okay. There we go. Okay, so now use CMake, which organized the. Wait, what is CMake? Hold on. The reason you didn't see main in the top folder is the modern versions of Whisper CPP, and the way you likely ran the build now uses CMake, which organizes the output into a build folder to keep your main directory clean. Okay, so do we have a main build? Seeing a build, are we? Include CMake build. Here it is. Okay, so decoding your find results. So inside of build, okay, build bin main. Oops. Okay. Build bin whisper, build bin main here. So we want this whisper CLI. This is the older one for the same tool in your version. Both exist. Likely one is a link to the other. Okay. Like whatever, a symlink. Or, other results. These are source code folders or specialized versions for Android or Java. Yeah, we can just ignore those. We don't care. Your engine is located at here. Okay, so I'm guessing we just put this entire thing into. Yeah, like this. Awesome. So whisper path. Let's just do that. Here is what we're doing. Okay, so then this one is the same, right? Models, yeah. Okay. So the terminal is smart. It sees the tilde and instantly swaps it for the home Timothy. Okay. Before running the command. In Python, you need the absolute. Awesome. Handling English and Chinese, since you are using this, you have multilingual mode. Whisper is very clever. It usually detects the language automatically, which is also what I was kind of like amazed by. Is I was expecting, the question I was trying to ask was like, can it even, like, if I just speak in Chinese, does it recognize that I'm not speaking English? And not only did it not recognize that, or not only did it recognize that I was speaking in Chinese and not in English, but it auto translated it, which was not expected. Okay. To make it faster and more accurate on your Orin Nano, you can tell the command which language to expect. That's not what we're going to be doing right now. Okay. Managing the when you run the script, PyAudio, it uses almost no RAM. Good. It's just draw for data. The whisper starts. It will grab about 800 megabytes. Okay. If you find the system gets sluggish, and we can do HTOP, GPU accelerated. Can actually run on your GPU instead of CPU. Whatever. Okay. Okay, let's copy this. Move this up because I have that little thing that's like what did I call it? Like sound example recording. Okay. Example, yeah. Okay. And then go into it. And then for example one. Oops. We'll figure that out later. Was it Shift A? No. Command A? No. Control A? There we go. Touch here. But there, I know that there's a Linux command that I did this, and then you can do like, there's something that you'd, I forget what it was, copy, or, anyways. So, I don't know if I have. Here we want insert mode, we want darn. Okay. So let's just come here. Copy you, paste you, and you don't work. Okay, great. There we go. Okay, so escape, write quit, and now we can, I need to delete the, awesome. Okay, so follow-up question number 1 is based off of this. I remember that there was some kind of command that I can use if I did the command touch example1.txt, and there was some kind of thing which was either copy or move or replace, which would allow me to just change one file to the other, because I accidentally did .txt and I didn't want to do that. I wanted .py. I remember that I could create a file and change it at the exact same time with one command, but now I am trying to realize what that command was, comma, and how to remove the example.txt file now that I've created it anyways, period. What are those two commands, period? I think it's like rm. It wouldn't be directory, right? Anyways, whatever. Whatever, it doesn't matter. Python 3, what did we even call this? Example1.py. Should we try it? PyAudio. Darn. We forgot the pip. We forgot that pip, didn't we? Come on now. Okay, I don't want to do this. I don't want a virtual environment. I just want it to work. Okay. Whatever. We're just going to do it like this. Could not build wheels. Okay, fine. Great. Awesome. Wonderful. I'm so glad I have this result. Okay. So now we're going to do 2 is like that, and 3 is here is my current code. What do you think? All right. And we can close you. All right, so it's the MV. Okay. To rename, use MV. Okay, renaming is just moving a file from one name to another. So move example here. Okay, so to delete. Okay, we just do RM. I was thinking RMDIR, but I was like, that's directory. So RM, and then example1.txt ls, and we are good. Redirect or shell expansion, but usually if you want to create a file and open it immediately to start coding, you can do nano. Okay, yeah, that's fine. Portaudio.h is a Python wrapper around a C library called portaudio. When you did pip install, Python tried to compile the C code, but it can't find the header. Awesome. So okay. Well, let's just do pip install. Yeah, whatever. Jetson. All right, so you're gonna do, how big are you? Oh, you're really small. Okay, fine. So, but there's one right before closing this stop stream. Oh, okay. Stop stream. Okay. Then we need to come in here and do this same pip install here. Okay. And we also need to make that change. Okay. Let's have some more. And it worked. Okay, cool. So now we want to, right. I want what this one was start, and now we want stop. Like this. No. So, and now I should be able to Python 3 example pi. Okay. Wonderful. Okay. You know, I could go through all of that. Or oh man, sometimes I just get lazy. I honestly, like, sometimes I just get lazy. I could look at this, try to understand what's going on. Okay. Oh, unable to find definition for card 0 PCM. Am I asking for card 0? I'm like right in the way of everything. Channel 1. Where am I actually asking for the hardware, right? Oh, it should be in this open, shouldn't it? Doing this. Hold on, where's the actual connection to the that command that we ran? Do you remember? It was that weird command that I was like, what's this? The A record or something? Anyways, it wouldn't be any of these. The only thing that I could think of is that, but there were two numbers. It was like card 1 device. Let me just A record minus L or something. I can't remember. Card 2 device 0, I think, is what we want. Right. So I'm gonna come in here. What is this error? And does it have anything to do with the A record command? Because I am noticing that I don't see where we actually use the card and device which we found to be in that A record command which we used a while ago, period. Okay. Go. settings. The driver is trying to look for standard features like surround sound, front speakers. Okay. The real error, invalid number of channels. The kill shot here, OS error, invalid number of channels. Let's look at that though. Where do we see that? Okay, so we have all of this nonsense, right? It said don't worry about the ALSA. It's fine. It said we look at here expression validate parameters, set of host here, file. Okay, here it is. OS error, invalid number of channels. Okay. So we did one channel, right? So home Timothy agentic AI example sound recording here. So line 49. Right there, audio recording, right? Audio recording, yep. And then comes to here, line 18. So in this file, line 18 in audio record. So 18 here, the stream.open. Audio record stream audio.open right here. And we're passing in channels right there. So I'm guessing that's what it's going to be complaining about. But we're also practicing, you know, looking through this kind of stuff. And file. So this is the file that it did. So this is different. This is not my file anymore. This is .local lib python 3 site packages. So pyaudio is being initialized, right? So we're calling the init on pyaudio. This line within the pyaudio in open here. Then we go into the same pyaudio, but at a different line. We go to init, so self.stream, so private variable called stream, PA open with arguments, and it didn't like that. Okay, so that's kind of where we're at. Awesome. So, this, I keep trying to rest on my elbow, but I don't know if you can see that. I ended up like, I was getting into work, and I had my backpack on. I had my I had all of my stuff. And I was like a little bit rushing because I had to get into a meeting, and I ended up missing the here's like here's the parking lot, right, and then there's the curb and then the sidewalk to the building, to the like office, right? So I was kind of rushing in, and I missed the curb, and just like bam, like I scraped up my hands. Luckily they're like better, you can't really see it anymore. This was a week ago. I scraped up my arm. I like bruised my hip and my legs. So, and I scraped my legs as well through my pants, and I'm like, oh, okay. I grabbed my stuff back up. Luckily, nothing broke. And then stumbled into the meeting, or like stumbled into the. Luckily, I wasn't late, but it was like, I always like to get to the office like early so that I'm able to, you know, just like kind of decompress a little bit, have a few, anyways. But there was a meeting that got moved up in time, and I normally like do my morning meetings, like the daily stand-ups and everything here from home. That way I miss traffic. But then they were like, "Oh, there's a meeting scheduled, so a little bit earlier than I had a separate meeting earlier than I had expected." So I'm like, "Ah, okay." It got moved up, so I needed to bam. Oh. Now every time I do this, I just like I realize, or I remember, oh, okay, never mind. Let's not do that. This is because of mismatch between your code and your hardware. In your script, you set channel here. However, many uh, combos or USB sound cards hardwire their input to be two channels, even if there's only one physical microphone. Okay, so as for hardware, hey, give me one channel. The hardware replies, I don't know how to do that. I only have two. You hit the nail on the head. In your Python script, you have this line. Input devices index 2. This is where we use the information from a record, but a record told us that USB audio is card 2. We tell PyAudio to use index 2. However, input device index doesn't always map perfectly to the card number if there are other virtual devices. Let's verify exactly what index PyAudio thinks USB mic is. Okay. I really wish that I could develop on my desktop. My desktop is right behind me. It's a Linux environment. I like both Linux and Mac, but I don't like laptops. That's my thing. I really like desktops because with a desktop you can be down here. You can just type like this, and you have your my monitor is like minuscule. It's almost as big as my laptop desktop or my laptop monitor. So my desktop monitor is almost as big as my laptop monitor, and my laptop is a MacBook Air, so it's really small. Um, but I just like my desktop because I can just like your posture is a little bit better and everything with my laptop. I'm just like I feel like a gremlin. So run this tiny scanner script. It will tell us exactly what index to use. Create a file called, you know, I could do it this way, but I know that I can also run Python from my terminal. I want to try that. Okay. So instead of running this in a file that I create, comma, I know that I can run Python from within my terminal if I just want to do a single action and don't really need to save my code, period. Can you tell me how to do this? Period. Okay. I think it was just like Python 3 but with no arguments, and then you just paste it in. Based on what the scanner tells us, update the main script. If the scanner says max input channels 2 so we need to change that. Even if you record in stereo 2, Whisper is smart enough to handle it. Okay. The busy device error. Potential next step. If you get an error saying device busy, it means another program like desktop audio mixer is holding the microphone. Since you are headless, this is less likely, but keep it in mind. Okay, whatever. Device busy might mean something. Okay. So now I'm actually just gonna come in here. I'm gonna let's commit. So get status. Get commit -m adding examples for how to capture and process audio from the Nvidia Nano with an attached speaker microphone combo. Git push origin main. Okay. So now what we want to do is we need to come in here and change our channel to be 2, and we're also going to do that in here. So we're gonna insert mode. Where do we want to do that? It's up. Okay. So let me just try to run it again. It might fail, but I think it's gonna fail because we don't have the right cards and everything. But you know, let's see if we get the same thing. So invalid number of channels. Hold up, hold up, hold up. Cat, changed, right? Channels 2. Okay, well, see. Okay. Okay, so you can run Python code directly from the terminal using the C command. It's great for quick checks. Okay, so Python C and then import. But this isn't exactly what I was imagine. I remember that there was something. I remember that there was something where I would type Python and it would give me a prompt and I could just type in my code and execute it each line by line, period. But I cannot remember when or where I saw this. I just remember that I was an interactive thing that I was able to do, period. Okay, to execute the following code, we're just gonna do this though. Paste that into there because we want to see what the, awesome. So now we're gonna copy that and paste this into here. So number 2, paste that into there. Okay. So it's still through the error. This usually means 2 things. Indexing is wrong, even though this says card 2. PyAudio might see it is a different index. Sample output is very picky. Okay. Update my script. Once you run the code in here, you will see a list like this. No, we do not, but that's fine. Use the index number here. Add exception on overflow is false to your stream to prevent it from classing if the CPU spikes. Okay, we'll do that later. Scan says, okay. Number 3. I guess I am confused because we are seeing multiple different things, which is a card number and a device number and the sub-device number, period. But I would think that I need to put all 3 parameters into my Python, but in your code, I see actual index, and this actual index only has a single number associated with it. So how does this connect to the actual device? Question mark. Okay. More coffee. All right. Want to fix it. Why is it? Man, you access it simply by typing Python 3 and hitting enter. That's what okay, I thought so. A is equal to 2, print A. There we go. Yeah. Okay. Exit. Haha. Okay. Yeah. There we go. Okay. Here. Since the one-liner failed, use the ripple you mentioned to get. What is ripple? Ooh, ripple. What's going on here? The interactive prompt. Oh, that's what it's called. Ripple. Okay, yeah. The thing you are remembering is called ripple. Read, eval, print, loop. So it reads what I say to it, it evaluates it, prints it. Okay. Okay, so you'll see this prompt here. Exit and or Control D. Good. Okay, so let's do the ripple method. So Python 3 here, and then from this I can just copy and paste. Okay. Oh, is it like spinning? I don't know. Oh, what's going on here? Okay. What's going on here? Question mark. And also, I'm noticing that I don't have access to my prompt anymore. Period. Is this because the code is still being executed? Question mark. How long do you expect this to take? Question mark. Okay. The other thing that I'm now like trying to do is every time I come into a problem that I'm like, man, it would be convenient if I knew how to do this little shortcut. I need to actually look up those shortcuts because like what I noticed about myself is I will do things the hard way over and over and over instead of just learning how to do it the simple way. An example of this is right here. I want to just delete this entire line, right? So I accidentally pasted my prompt into the actual terminal, period. You can see 3 dots and then the prompt which I was initially trying to give to you, period. I want to know what are those things which are the 3 dots and what does the 3 dots actually indicate? Question mark. The other thing that I'm curious about is how do you delete an entire line in the terminal without just using backspace to go through and delete everything, period. Or question mark. But yeah, so normally I would just have it, or like I would come here and just do delete, or like just like backspace the entire thing. But I really want to change my mentality to say like, okay, well, if there's something that's causing me trouble over and over and over, I just need to like I should learn. I should be lazy, right? You want to do it the lazy way, or actually, it's not even the efficient way. You should constantly be looking to be efficient. This is the heart of your confusion. Let's visualize it. So ALSA, the OS driver, sees things such as card device, subdevice. This is the physical address. Okay. 3 here. By physical address, are you meaning that the operating system is able to write to a specific address in its actual memory, parentheses, as opposed to its virtual memory, end parentheses. And this is memory mapped to the physical hardware device. And when data is put at those addresses, the transistors within the CPU open up such that the data is flowed to the physical hardware device based off of the data register and the address register, question mark. Is this what you were talking about, question mark? And if so, how does those three things give me information about what the actual address is, because I'm not seeing any memory address in those informations, period. I don't know. Okay. Pi Audio scans all those physical. It's still going. Like, what is this? Okay, when Pi Audio starts, it looks for the system that says, okay, card 0. Hold on. I was just reading, but I was not thinking. Okay, Pi Audio. The Python library scans all those physical addresses and creates a simple list. Oh, okay. So the OS has its devices, right? And then Pi Audio looks at the physical addresses and creates its own indices. When Pi Audio starts, it looks at the system and says, okay, card 0, device 0, that's my index 0. Okay. Index 1, index 2. Sometimes the Jetson creates virtual devices like internal pulse audio bridges. This can shift the number 0 to 10. Okay, index 11 might be card 2, device 0. This is why we need that information. Okay, so updating my code, the stereo fix here. Even if it's... Let's try this specific change inside of here. I don't see why that would... I don't see why that would have an effect, right? Because it's... The error that we're getting is number of channels. So whatever this was, I don't know. Next question 1. This is the actual error which is given to me, comma, so I'm wondering why you think changing the rate to 44.1K would have any effect on this error, period. Remember that I'm also trying to understand the concepts, not just fix the specific problem, period. All right, so there we go. And we need no, it's still there. What does 3 dots in REPL? The read, evaluate, print, loop? Hey, I got it. Loop. Okay, I was like, I don't think that it's loop, but it was. Okay. So in REPL, read, evaluate, print, loop. I'm trying to say it multiple times so that I just remember it, right? The triple prompt means I'm ready for new commands. When you type for I in range, you start a block of code. Python sees a colon here and knows you aren't finished. The triple dot is Python saying I'm waiting for you to finish the specific dot or block of code. How to get out? Since Python uses indentation to know when a block ends, you need to hit enter on a completely blank line. This tells Python I'm done with the loop. Please execute it now. Is it still executing? No, it's paused. Okay. It won't run a single line of that for loop until it sees the final empty line. Got it. Okay, so deleting a line without backspace. Here we go. So this is just improving our efficiency. that are much faster than backspace. Delete or Control U deletes everything from the cursor back to the start of the line. K deletes everything from the cursor to the end of the line. Okay, so U, K is to the end of the line. Okay, so Control C kills everything. Okay, so let's experiment with Control K first. So, 何在干啥? Okay. Well, I'm completely frozen, so. Okay. Well, there we go. Exit. Okay. Well, that was a little bit less exciting than what I was hoping. Let's come back up here and let's do the exact same thing, right? So I'm gonna say Python 3 here, paste that in, okay? Then I'm gonna come here, okay? And then I am going to write something ridiculous, okay? Then I'm going to come here and say, oops, I made a mistake. So we're going to do Control and then K to delete everything here. Oh, come on. Or here we are. Okay. So Control and K. Good. Good. Control and U. Awesome. So now, okay, so we did this. You started a block of code. Python sees that colon, which we did here, right? Or here. There's 2 colons. And the reason why I'm trying to go into this a little bit more is because, okay, well, back to that thing about efficiency, and obviously I might be able to just do this a little bit faster. Just create a new file, throw it in there, and press go, right? That's the way I would have normally done it. But, okay, now I didn't learn anything about this REPL, right? So I need to constantly be thinking about how I can grab new information and learn new things. Because I realize that I'm very single minded. I'm very like, I know one way to do it and I do that one way. But I really want to start expanding my view of things. Okay. So how to get out of it since Python. Okay. So for here, sees the colon and knows that you haven't finished yet. The triple dot is Python saying, I'm waiting for you to finish this specific block of code. How to get out of it. Since Python uses indentation to know when a block ends, you need to either hit enter on a completely blank line. This tells Python, I'm done with the loop. Please execute it now. Okay. Hit enter on a completely blank line, like what we're on right there. Okay. Is it still executing? No. So what I need to do is I need to press enter. Okay. And then we're going to be right here. So press enter. Okay, there we go. So now I'm looking for this. So I want index 24. Okay, so exit here. VI example 1, and I want 20. Oh, what did I just say? 24, right? I should have actually captured that a little bit better. But anyways, 24, here, 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 24. Okay, and we are going to run you, actually. Python. Oh, man, what? Why are you still frozen? That was nuts. What? Oh, okay. I was excited to run it. Okay, integrated here. You have a very sharp intuition about memory mapped I/O, but there is a layer of translation between the CPU and the USB device. Okay. Your theory. You are describing how a CPU talks to internal components. Yeah, that's what I'm doing. But I want to know kind of how the operating system works with that, right? Like RAM or integrated GPU. Exactly. By sending bits to specific physical memory address. Yep, that's what I'm meaning. Okay, so now it's different when we're talking, instead of talking to physical RAM, we're talking to a device, so a USB device. Don't have fixed physical memory addresses in the CPU's direct map. Got it. Okay. The USB controller, a piece of hardware on your or a Nano, is memory mapped. Okay, so let me reread that for a second. Are you up yet? What? Oh. Jetson. Okay. Well, here's a question. Obviously, I think we know what we were going to ask. Um, Let me give it a little bit of more context here. So, paste that in there, and I had just finished editing my example1.py to change it to be index 24, comma, but then I lost control of my screen and was not able to type anything, and then I got this message saying read from remote host Jetson local. And now I want to understand why this might have happened and what might have been occurring. Period. What do you think is going on? Question mark. I already solved the problem by SSHing into it again, but I'm trying to understand the concepts of what might have occurred. Period. All right. Here. Okay. We're just going to put this in the context window as well. So this is number 2. As you can see, I believe that the device which we are looking for is index 24. I have changed my Python code accordingly, period. All right. So I still want to go through this, but I also want to alas agentic. Did I lose control of it again? In point number 1, I said that I had that error and I SSH'd into my Jetson once again, period. As you can see in this snippet I just gave you, period, the top is from that time that I SSH'd into it, period. But now I get the exact same error after I changed directories into my desktop. I'm really confused about why this is going on, how I can stop my Jetson from actually locking up or crashing or whatever is going on, period. Okay. And it gave me this here, so I'm going to copy this. What is desktop here? Okay. Your theory. Yes. Here. So USB devices don't have physical memory addresses. In the CPU's direct map, instead, the USB controller, a piece of hardware on my Orin, is memory mapped. What does that mean? Give me an example. Oh, what are we on? Question number what? 3, 4? Okay, so 4. I don't understand what you mean by this. Can you give me an exact example and walk me through exactly how the memory is used? Question mark. I have worked a lot with embedded systems with no operating system and looked at data sheets of physical hardware components and used I2C for writing data into registers of those physical hardware devices from a microcontroller, period. So feel free to use examples or knowledge of this when explaining, period. Okay. So now, here. So does not see memory address F. Is that a 0 or O? FOO. It sees USB bus. Is that it? Oh, wait, no. That's a. Okay, I was. Normally it's a. Like a. Like this, where it has a little line going through it. That looks like an O. But then I realized here that's a. This has to be a 0, right? And I was like, well, that would be an error. There's no O. There's no hexadecimal O. Maybe that was the error. And then I realized, oh no, it was just the font. Okay. It sees the USB bus. It doesn't see memory address. It sees the USB bus. Card. The specific hardware controller device. A logical stream. Okay, let me take a second. Let me just catch my breath a little bit, and then I need to take a sip of coffee, reread that line, try to understand what it means. I should have gotten a cup of water before I started this video. Okay, so ALSA roll. So it doesn't see the memory address here. It sees the USB bus. Card, the specific hardware controller. Okay. Device, a logical stream. The controller provides subdivide. Okay. What are we on? I think 5. So can you explain every point in this and explain it in the context of Linux and how this actually is operating with the /dev/etc/lib and how the kernel is dealing with all of this, period. Please give a full and extensive walkthrough of how all the components are working together and how transactions are able to be completed from the highest level action all the way down to the hardware, period. Okay, so when I use this ALSA, I forgot who ALSA is. Okay. Also, please make sure to say exactly who ALSA actually is and in which stack this character is living, period. And is the USB bus part of the physical wires, or is this a virtual thing? Question mark. Okay, so why talk about rate? Yeah, in the world of hardware drivers, especially the older ALSA, again, we don't know what that is. Error messages can be bundles. Okay, so the negotiation. When Pi Audio opens a stream, it sends hardware parameter structure to the driver. Hardware parameter drivers, hardware parameter structure to the driver. This structure includes channel rate here, the rejection. If the hardware only supports 2 channels and this rate, the driver might fail the entire structure. Okay, so sometimes the driver just reports the first thing it noticed was wrong or sends a generic invalid argument. Okay. Hardware has native modes. If you aren't in native mode, in a native modes like 2 channel, the hardware literally cannot. Oh, okay, interesting. What are we on? 6? Okay. What do you mean by native modes? Question mark. I have not heard about this before, period. And how does this connect to the actual C++? Question mark. I'm assuming that I would be able to go into the actual code for C++ and see the lines of code which are actually failing and investigate the parameters which I need to actually put into this to be able to get the correct channels and frequencies. Comma, is that correct? Question mark. Because that seems like the easier way to go about things is if we keep like guessing, like, oh, I think it's 1 channel, oh, I think it's 2 channels, oh, I think it's this frequency. It's like, well, now all of a sudden, let's say that we had 5 parameters, and each parameter they could be like whatever. Channels could be up to 12, right? So let's say that we have 5, so that's what would it be, 12 raised to the 5 or 5 raised to the 12, or I need to go back. Hold up, that's gonna be another question. Okay. I was thinking about this question of randomly guessing different parameters and options for them, period. Versus, actually, just looking at the code, period. The thought which I was thinking is if we have 5 variables and each of those 5 variables can take on 12 different values, comma, such as channels variable can take on 1 through 12, comma, I was trying to think about how many combinations or permutations this would be, period. I was initially thinking 5 raised to the 12, comma, or 12 raised to the 5th, comma, or something with a factorial, period. But I was unable to reason through how the mathematics would actually work and why, period. Please explain what I am thinking and explain all of those different things, period. Why would it be one versus the other, period. Okay. How to finish? Okay, so man, we are in in the weeds right now. Okay. Here. So broken pipe. Operation SSH sends keep alive packets. If the Mac doesn't hear back from the Jetson within a specific time frame, it assumes the Jetson is dead. Closes the pipe. Got it. Okay. Why did it happen while you were in VI? Network instability. Since you're using .local, you are relying on multicast domain name server. If your Wi-Fi fluctuates, the Mac lost the. Oh, I'm actually not doing anything with a router. It's a direct connection through USB. I actually don't want my Jetson in the sun. Hold up a second. Okay, here we go. The sun has changed locations, and I don't want my Jetson cooking in the sun. There we go. I'm gonna protect you. All right, so the Orin Nano freeze. The Orin Nano, if you are running heavy process like loading a Whisper model you haven't set up, and you haven't set up memory swap, yeah. Okay, maybe we will need to do that. The CPU can hang while trying to figure out how to allocate memory. During the hang, it stops responding to network packets. Wonderful. If your Jetson isn't on a stable power supply, okay, so this is the only thing that I can think of. Dang, I do not want to do that. I don't want to do the swap because it's gonna make the because I purchased the not RAM the NVMe, right. I purchased the NVMe, and I'm worried that if I do this swap thing, it's just gonna make things more complicated when I. Okay. So this is the only thing that I think might actually be happening, period, because the network instability does not seem to be a valid concern because I am not using my router through Wi-Fi, period. Instead, I am directly connecting the USB-C to the USB-C on my laptop and SSHing in through there, period. The power supply is also stable, period. Okay, so now what? One of the concerns that I have regarding the swap memory is because I'm still on my micro SD card and I have recently purchased an NVMe SSD. I am worried about the transition and how difficult it will be to do the swap memory right now, and then when I try to transfer over to my NVMe memory later, that it will make things more difficult. Is this a valid concern? Question mark. What are your suggestions? Question mark. Okay. Also, is there a way to determine the memory being used on my Jetson right now? Question mark. It's just gonna be a further follow-up. I think we're on to whatever. In your previous experience with microcontrollers like STEM32 or Arduino, you might have used I2C to write registers at address. Man, I want to take a break, but I also want to keep going. I want water. That's what I actually want. I want water. Especially because when you do these videos, you're talking, so your throat like dries out. Coffee helps, but it doesn't hit the same way as some nice refreshing water. Although I have this. right? Like, look at this, like cream. I know that these things are so unhealthy. They're so unhealthy. But sometimes in the past I drank Mountain Dew like a lot. I drank a lot of Mountain Dew. I would have like uh about a can per day. And sometimes I would have like two cans per day if I really wanted to like focus. Like I would just and then go. But then I stopped that because I was like, this is probably really unhealthy, and I switched over to coffee, um, which, again, coffee it doesn't hit the same way. Whenever I have a Mountain Dew, I can enter kind of like a flow state. Coffee, it's just like kind of gets me a little bit focused. Not really, it doesn't, but just like it was something to switch over. But then recently I was like, okay, maybe I'll try like maybe have one of these things. This is a big can though. When I'm talking about Mountain Dew cans, I'm talking about like this size, right? This is a big can, you see. Um, but yeah, so maybe like one a week. I don't know. I haven't had I haven't had one of these things in like 3 weeks or something, 3 or 4 weeks. But I was thinking like maybe I should just give myself some leeway. Enjoy life. They taste so good. That's a thing. Mountain Dew, the blue kind. Mountain Dew, the blue kind, tastes so good. You would just. And from that first sip, here we go. Here we go. Right? Um, but yeah. So the microcontroller way. Or what was I even talking about? Right. So then I did that, and then um, yeah. So the microcontroller way. The CPU puts hexadecimal 40 on the address bus. Yes. The I2C peripheral hardware. Peripheral meaning like external to the CPU, external to the CPU. It can still be on the baseboard, but hardware sees this and physically toggles the clock and data lines. Okay. Yes. The Orin Nano is a system on chip. It has a. Okay, so. Why did you specify this term of system on chip? Question mark. What does this mean? Question mark. And how is it different than a microcontroller? Question mark. Okay, so I've heard this term system on chip before, and I always just associated it with like, oh, it means that it's a computer, like it has an operating system. But I want to know the actual, legitimate, exact definition. It has a USB host controller integrated into the silicon. Okay, what's that? Host controller. What would this do? Okay. Question number 4. Ding, ding, ding. What does this look like? Question mark. And can you go into more detail about what this actually is? Question mark. Integrated into the silicon. So I'm guessing what it means is that we have, I guess, what I think this line of means is that we have, let's say CPU, but the CPU is actually a system on chip. And what system on chip means is that you have many different components integrated into this CPU. It's not just a CPU, it's a CPU plus a USB host controller integrated within the actual like silicon logic gates, right? Whatever written in like what was it? VHL, very large, VL, very large, VL system integration, VLSI, maybe. Um, when you say that this USB host controller is integrated into the silicon, comma, does this mean that FPGA programmers actually went and wrote the Verilog or VLSI code to change the transistors within the CPU to be able to run logic associated with the USB host controller functions? Question mark. How would this look? Question mark. How would you actually write the code? Question mark. How do you use the code to put it onto the silicon? Question mark. If we have a system on chip, comma, it is not an FPGA, so how do you use the logic to change the transistor gates? Period. I have a degree in electrical engineering, comma, and I took a digital logic class in my sophomore year a long time ago, so I very fuzzily remember these concepts, period. Please refresh my memory, period. There we go. Okay. Ah, now the sun is like right in my eyes. Okay, so to get audio from, we are really getting down into the weeds. And this is something that I know that I need to it's like my habit. It also might be because I have, like, by trade I'm an electrical engineer. I always go down, 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 down until I hit the base level, right? But a lot of times we need to stay up here to actually get something accomplished, right? So I feel like I'm going a little bit too down, but I really want to understand it. It's interesting, right? So, all right, so memory mapping. The Linux kernel maps the USB controller registers to a specific range of system memory. While I'm doing that, let me try to rerun this. Okay. Hopefully, if it pauses again, I am going to power cycle it. Actually, I can do sudo reboot and just power cycle it from here. All right, so to get the audio, okay, so the Linux kernel, right, maps the USB controllers, USB controllers registers into a specific range of system memory. Okay. I'm sorry. I can't help myself. It's a personal project, okay? It's a personal project. We get to explore a little bit. We get to explore a little bit. This is not work. We don't have deadlines. We're learning, okay? I want to go down. I want to keep going down. Who exactly is the USB controller? Question mark. Is that a driver on my Linux operating system? Question mark. Is it located in the actual speaker? Question mark. Is it software? Question mark. And how would the Linux kernel even be able to communicate with it to be able to start the mapping process? Question mark. The transaction. To get audio from your USB mic, Okay, yes. The CPU doesn't talk to the mic. It talks to the USB controller. That makes it sound like it's something in like the dev folder. It tells the controller go talk to device on bus 1, address 4, and tell it to send me audio packets. Okay. Number 7. This makes me think that the USB controller is a device within the /dev folder of my Linux. And the operating system is now going to be sending system calls to the dev folder of the device with bus and address information, comma, is this correct, question mark. Also, how would the /lib, which contains the drivers, interact with this process, question mark. And how do we actually know which driver we are trying to use and what device we are trying to use? And what do the system calls look like to be able to talk to it correctly? And how do we pass in parameters and how do we pass in data? Question mark. I want to know all of this and understand the concepts of Linux, period. All right, the buffer. So we're almost not even doing anything anymore. We're not even developing anymore. Jetson. Come on. Okay. We want to go into desktop. Who's out there? Oh, okay. Desktop, it's neighbors, it's fine. And okay. I want to go into my agentic AI, yeah. Okay. Okay, there we go. So that's another trick that I saw. So then this is the sun. Woof, woof. Okay. This is something that I've really realized is the importance of like trying to really surround yourself with people who are competent and you can learn from, because whenever I'm developing, right? I'm just developing by myself. The company that I work for, I'm the only I have three roles: embedded systems engineer, firmware engineer, and software engineer. Right. So I have three separate roles, and I am the only person who does any of those three within my entire department. Okay. And so everyone else is strictly hardware, hardware, hardware. I'm talking about PCB design, like actually creating the schematics for it, and then my job is to integrate, like embed the we have the microcontroller, right, to be able to control those hardware devices, make sure that the voltages are correct on all of the outputs, what all of that, right? So I don't get an opportunity to interact with people who are competent within. I don't want to say that they're not competent in software. That's not what I'm trying. Well, I mean that's not their job, but I think you know what I mean, right? They are hardware engineers. That's what they do. Um, but if so, Susie actually came here to Oregon, uh, like last week, which is why I haven't been making YouTube videos recently. And Susie is software engineer, and I was with her and just watching her. By the way, so the context to Susie is she's a oh my goodness, She is a software engineer at Amazon. So we went to school together, and then I started at this company. Then went to, like, she graduated a year after me, a little bit less or over a year. So whatever. I have 2.5 years of experience at this company. She has 1 year of experience at Amazon. And so she's been surrounded by software engineers. And I was watching her, and she was so much more competent in just how to use these systems, how to flow through things. And one of the things that I saw was she would do like this, right? And normally when I would press like whenever I would come here, I would do this, these two words, which will trigger my little Apple Assistant that I don't want, and then it do this, and then it would come here, and then I would be like, oh, I have so many different ones. I can't remember which one I had. So then I would have to come back here and then do an ls, then come here and be like, oh, okay, I have these two options. But then she went like that, like double hit the tab, and it gives you the options right there. So you don't need to delete it, do the ls, and then see it, then do type the change directory, and then this again, right? Again, back to that efficiency thing. And it was just like looking at other people, how they are doing things, and being surrounded by those people who are like competent in what you're trying to do. So important, because I did that just now because I learned it from her like a couple days ago, and it saved me a bunch of time. Well, not really, because I'm started yapping for about 5 or 10 minutes on this. I don't know how long, but anyways. So now, what am I looking for? I am looking for sound recording. There we go. See how easy that was? But yeah, it's a lot of those, like, it's the big things, which are kind of obvious that you learn, like, then it's also the little things, like, oh, I didn't know that I could double press tab. I would always just do like tab, and then it wouldn't have anything, and I'd be like, okay, well, there we go. I guess I need to backspace, ls, enter, look. Okay, now those two letters, and then see, once again, back to my mindset of I know this about myself. I do things the way that I know it. And I need to be much more, I need to try to expand. That's what I'm trying to do. I'm trying to grow in my competency. I do see that I need to plug my laptop in though. Hold up a second. Ah, come on. See all these wires. It's all messed up. Everything is so disorganized right now. Oh, and even better is I plugged my Nvidia Nano in, so I cannot oh, fine. Never mind. I cannot. We should have enough time. I was just looking at my battery, and I was like, I wish I want to plug in, but if I do that, the power to my Nano is going to be taken away. So let's need more power units. Anyway, okay. What am I trying to do? I am trying to. Can I go like this? Haha, I can. Okay. That is so cool. 3, and then I should be able to go like this. Oh, I think it only. I was going to say, like, if I have multiple files, but I only have one file, so it did that. It automatically knew which one I was trying to do. This one shows all of the different commands that I can do for starting with py, right? I could do Python 2.7, I could do Python 3, I could do 3.10. 3.10 like get the configurations or whatever. So that should mean that I can do something like Okay, hold on. Control U. Ha! There we go. See, no backspace. Practicing. Okay, so I should be able to do, let's say, what's a fun uh command in Linux? What are some fun commands? No, I don't want to do networking actually. Um, what? I'm just thinking of any command. But there's thousands of Linux commands. Like, okay, so it's the abundance of things. Let's just do. Um, well, what I'm trying to test really is this. There we go. So rgrep. Okay, so what I was trying to do is I was thinking about trying to ask for a command, right? And then let's say that I didn't know exactly what that command, like how to spell it or something like that. Let's say that I was trying to do this rmdir, remove directory, that we were thinking about in the past. I was wondering, based off of this, it appears that I can just start typing the executable, right? Because that's the way Linux goes. You do the executable first, and then you do the arguments that you want. So like executable is rmdir, so that's within your etc folder. I can't remember, bin folder maybe, but it's an executable in there. So I start typing the executable, and then I can press the tab, and then it gives me all of the options for the commands, because that's what I'm typing right now, which match here, and I can look for this rmdir or any of the other ones here. So yes, that is valid. That's so cool. Okay, and then there's reboot right there. So if we were thinking like, let's look at our, okay. Oh, what am I trying to do? Python, right? 3. Okay. And so that makes sense because it couldn't complete it because I did py, but then there's so many other ones, and it's like, I don't know what you're looking for. Then you can do Python, but then it's like, well, I don't know what you want with Python. It could be Python 2.7, it could be Python 3, it could be Python 3.10, it could be Python 3.10 config. Anyways, okay. Once again, we are way completely off base. And then I should be able, control. I don't want to really do control U. So what I could do is that control K, right? So watch this. Control K. There. Okay. Awesome. So we still got the same thing. And I want to cat my example. So that way we can put it into here. So this is number 8. All right. You asked exactly who. I thought I'm so confused. Not confused, but I'm so lost now because we have like 8 questions here. I can't remember what I asked in this one versus what I asked in this one up here. I remember asking who the ALSA actually is, but I thought that I asked it in one of these questions. Anyway, it doesn't matter. It's going to answer it here. Advanced Linux Sound Architecture. Okay, that's what it means. Is a component of the Linux kernel. So it's within Linux, which would make sense. Advanced Linux. Okay. So who ALSA is? Component. What kind of component of the Linux kernel? What does component mean? Is it a driver? Is it a library? Is it within the physical architecture? Or like the physical silicon? Like what do you mean component? Well, it wouldn't be in the like chip itself because Linux, right? That's the operating system, so it's not going to be the hardware. Okay, so layer top here. We're going to get this and it's a okay. What do you mean? It is a component in the Linux kernel, question mark. Is it a driver or a library or something else, question mark? And why is it called architecture, question mark? Component of the Linux kernel, great. So the top, so it's lives in user space, requests a stream. Okay, give me 44.1 kilohertz, okay? And this goes to a shared library, okay? A .so file, which is within, I believe it is our, where does shared, where do shared live? Where do shared objects live? I forgot. I think, yo, maybe I should just look. Maybe I should just look, okay? It's within the lib, user lib. Okay, there we go. So this is when we are going to be, so like oh my gosh, I'm trying to make sure that let me make sure that my number 10, I want to make sure that my understanding is correct. Period. Shared object files are living within the /user/lib folder, and they are compiled C code which has no main function and therefore only offers functionality of different C functions. Period. You are unable to actually run these code, but you can call functions within those files from your program which you are writing, period. Okay. Why is it not doing the period at the end? What are some of the things that I'm trying to think about? Is it actually compiled or is it the actual... Hold up. I believe SO files are compiled. I think that .so files are actually compiled, so we cannot open them directly and look at their contents, period. Which might mean that the code for this A sound is written in C somewhere else on my Nvidia Nano, and I'm guessing that it was compiled and placed within that location on my device. And so if I want to see the functions available to me for this libasound.so file, I will need to look at the location which the C lives to find the functions that I can call. Period. Another question that I have is how does it work calling the functions within this library from different languages such as Python or C sharp? Because if the original function is written in C, comma, then for C sharp, I believe I need to use something like pinvoke. And now that I am working on a Linux application, not Linux, I meant Python. Python application, I probably need to do something similar to pinvoke as well, period. Plus, I also remember something about trampolines in relation to C++ libraries, but I have no idea what that is, period. Once again, we are way off base. We are not even developing anymore, honestly. We're not developing, we're understanding the concepts. I don't know if we got too far into the weeds or I don't know. Okay, so middle, this dev SND, probably not sound, I don't know. So it's in the dev, the virtual file that represents my hardware. Okay, so this represents my hardware. So this is the device right there, which is in my devices folder. All right, now ALSA kernel driver. Okay, so now we have a kernel driver that lives in kernel space. Okay. The character that talks to the USB driver. Okay, so most of the things which I deal with have no operating system, so I am a little bit confused about user space versus kernel space, period. I noticed that you said the ALSA kernel driver lives in kernel space, period. I know that kernel space will have extra privileges and that we need to do system calls to be able to actually interact with kernel space drivers, period. But I want to know more about how kernel drivers are actually written, what they are able to do, comma, how I can interact with them, comma, how I can look at them and investigate them, comma, and even how I might be able to write one myself, period. More about opening up, just exploring different things. This actually talks to the USB bus driver. Okay, so USB bus. This is hardware. The physical copper wires carrying the differential signals. Okay. So the kernel talks to the physical hardware. Okay. Walkthrough. So here. Kernel call. PyAudio calls libasound, which opens a file in here. Okay, so here's the device, right? But then we have this. So within this device, there is a sub device, okay? PCM C2, card 2, device 0, capture. Okay. So we're on 12. 12. I noticed that SND is the actual device which is associated with my speaker, period. And then you were able to go one level deeper, and we have this PCM C2D0C, period. Would I be able to actually go into this file from my terminal, period? Because I know that devices are where you send memory, where you send data to. in order to write to the physical device, period. Actually, now on second thought, I'm wondering if this is the location that I write to in order to talk to the kernel driver, which I just asked about in question number 11, period. But anyways, I know that this is just a place that my system can write data to, period. So that's why I'm a little bit curious about how we were able to just change directories into the SND device, because I thought that the SND device was the location that I need to write data to, not an actual folder that has other files within it. And maybe now PCMC2D0C is the file that I need to actually write to, which I thought that I needed to write to SND file, but SND is not a file. It seems to be a folder, period. Alright, so the bus. The kernel's USB audio class driver tells... Ooh, okay. Audio class driver tells the USB bus to start in uh, isynchronous, but there's whatever, I don't care, transfer. This starts, this is a continuous stream of data on the physical wire. What does this mean? And are we opening up a socket which we are able to continually flow data back and forth, or are we writing one time, or how is that happening? Question mark. Okay. P10S chip in your speaker converts analog voltage from the mic into digital bits and sends them over the wire. Okay, so then the P10 chip is within, it lives within this thing here, and it actually captures it through, so it comes through, the voltages come through here, get put onto the PCB within here, right? And then there's a chip in there that takes that, has its ports, right, that takes the USB-C, probably some USB-C controller, or USB controller, right? And then is able to send that out to the microcontroller, and then the microcontroller takes that, it understands those commands, and then performs the operation. Okay. We're on 6 right now here. Let me see how much more we have. Okay. Native modes are fixed configurations built into the hardware's firmware. Fixed configuration built into the hardware's firmware. Hardware meaning the speaker, not the nano. Okay. Example, a cheap USB chip might only have one clock crystal for here. If you ask for 16K, the hardware literally cannot tick at that speed. Okay, so let me say the actual device which I purchased. Where did the... Here it is. Stereo sound microphone warning light. The USB PC speaker which I purchased is from a company called Punk Wolf, and I'm seeing data that says P1U4 computer speaker, period. Let's see if I can put something in here. The product specifications are scope of application, PC/laptop. Products include computer speaker 1, 4 core data cables, 1200 star 1, user manual 1. Oh, okay, oh, whatever. Anyways, it's not waterproof. Compatible with. Just trying to see if there's anything else that is like might be good to put into the context of this system. And then I also see set it to work on Windows. 1, plug it into computer USB port. 2, click sound icon in taskbar. 3, expand output. 4, choose USB as the sound output device, period. I'm just telling you these things for extra context so that you understand the situation a little bit better, period. The device. Okay. So here, the C++ connection. Do you have any information about this unit and what the settings might be? Question mark. And now I'm thinking that if the firmware is actually within the microcontroller of the speaker, period, that actually does mean that I don't have access to that source code, and I do need to guess all of those permutations, period. Or I can just go and look at the actual data sheet, period. That actually might be a bit. Okay. Do we want to? Ah! Copy. Hey, look. See? Ah. Command Shift. Copy. Okay. No, we are not doing you. Was it Control? Okay. Control Command C? I don't know. Not you. V. Whoa. Oh, right. Okay. Anyways. Copy. Okay. Never mind. That's why. I just saw that all of that green. Okay, so now we get to use our little trick. So what was it? Command and U. Control and U. There we go. See? See how much time that saves? Oh my gosh. You really need to go and just like, if there's something that you notice is taking up 10 seconds of your life multiple times per day, right? Or even like multiple times per week, just fix it. Just learn how to do it. And the other thing that I've been now I'm starting to like look for those things. Like where am I less efficient? Something else that I realized is like when I do my SSH in, I have to do these 2 letters, right? And then I do desktop, and then I do agentic AI, right? Well, I want to be able to do a command that just does like, and then, or just even like dev, right? And then I go bang, and then it just takes me to the right location. So I know that that's going to be something to do with, I think, my bash RC. I'm curious about how I can write my own commands in Linux, such as what if I want to do a command when I immediately SSH into my device, and this command will take me to a specific development folder. And this way I don't need to do so many commands to change directories into the right folder every time I log into a device, period. There we go. Once again, it might take more time up front right now, but then in the future, it's going to save us a lot of time. And we learned something along the way, right? Like we learn about I'm guessing it's going to be the bash or .bash RC file, and we just need to edit that. But it's a good learning opportunity as well. Ouch, my thing. Okay. The C++ connection. If you look at the source code for the Linux kernel USB audio driver, okay, sound USB format C, you would see a table of supported bit rates. Okay. Okay, so where is the sound? Linux kernels USB. Where is it? Okay. Investigate. You can see what your hardware supports without looking. Okay, so proc. Well, that's going to be another question. Is going to be you gave me two paths. One is sound/USB/format.c and /proc/asound/card2/stream0, period. I am now trying to find where this format.c actually lives so that I can go and use VI to look at it and investigate what's going on. But I don't know where it's living, period. The other one is this proc folder seems to be a standard Linux folder like ben, etc, and all of the other folders in the standard Linux folder system. And each of those folders have very specific tasks and functionalities which they provide. So I'm wondering what this proc folder is normally used for, period. What are some of the other things which might be expected to be found within this proc folder, question mark. All right. List every native mode, sample rate, the bit the mic actually supports, the math of combinations. You are asking about the state space. Okay, yep, that's coming back to me. State space, all possible configurations which is possible for a given outcome. So if you have 5 variables, let's say rate, channel, format, buffer size, index. Okay, so here are our 5 variables, and each has 12 options. The calculation is, right, okay, there we go. Okay, so it's for one, let's say that there's one variable. How many options do we have? 12. So if for our one, how many do we have? 12. Now let's say that we have 2 variables. How many could it be? Well, we could have variable 1 is selected as 1, okay? And then variable 2 is selected as 1 as well. Okay, so that's one option. And then this one could be 2. This one could be 3, 4, 5, 6, 7. And this one still is staying at 1, right? So we could have 12 here. Okay? And then this one could be 2, and then this would be 1. So that is, right, each one can take on 12. This one can be 12. This one can be 12. So it's 12 times 12. So it is going to be 5 raised to the 12, I believe. 12 raised to the 5. Ah, see, my math. My math. I have not been using math in a very long time since I graduated. What? That's about 3 years ago. Because I've worked at my company for like 2.5 years, right? And it took me about half a year to get a job. So I've been out of school for a very long time. Dang, I need to review my math, right? Right, 12. Because you're doing 12 5 times. Come on. Come on, brain. Should I? Right, like that's another thing about doing projects online, is, you know, sometimes you're doing stuff and it's just like, how do I say this? I think when you're actually developing, you run into all of those little mistakes. You you show a very accurate representation of kind of like, oh, here, I don't know this. I don't know that. No, that's not the right way of saying it. Like, even though if I were to truly think about this, right, and write it down and I could reason through it, right? But, and now, if you ask me, okay, I can very easily tell you, okay, yeah, it's, the, we're doing the 12 5 times, so it's 12 raised to the fifth, right? And like, I knew it in the past, I had forgotten it, and then it took me, what, 10 seconds to re-remember it. But because I'm filming this video and doing a project, like, you post all of this stuff online that, like, oh, this guy doesn't know this very simple thing. But actually, it's like, okay, well, I knew it in the past, I had forgotten it, and it took me 10 seconds to re remember it. But then it's like, this guy, it's not, right? Like, sometimes I get a lot of those comments like, um, I can't believe you don't know this. And it's like, okay, well, I mean, I learned it a long time ago in school. I know of the concepts, right? And I feel like learning it the first time, that's the difficult part. But then once you learn it, you do forget it, but it's still kind of in your brain or your subconscious. And then you're able to learn it a lot faster, like the second time. And because you know about the concept, you know to even ask, right? Like, this came about because I asked the question to the guessing of sample rates. And I was like, okay, I remember studying permutations and combinations and permutations in school. And I know that this concept exists, but I'm a little bit rusty on it, right? If I hadn't have studied it, I wouldn't have even thought of that. I wouldn't have even known that this is a concept. But I knew that it was a concept. And then once I knew to ask the question, learning it took about 10 seconds. Um, and so, anyways. Um, so, okay, let me just think about 12 factorial. So 12 factorial would be 12 times 12 times 12 times 12. Why is that not the case? Because we don't have 12 variables, right? Um, so 12 to the fifth, independent choices. Use this when you can choose option 1 for variable A, and that doesn't stop you from choosing. Oh, wait, no. Hold up. And I didn't look. Factorial does not mean 12 times 12 times 12. That would be 12 raised to the 12th. Okay. Factorial means 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. That's what factorial means. Okay. So when would this case be used? Again, I'm not going to be looking. When would a factorial be used? That is when we lock something in. I remember that in my class. We lock something in. So let's say that we have 12 seats. Okay. We have 12 seats and we want to assign a person to a seat. Okay. So we have 12 people and 12 seats. And the order matters, right? And I want to ask how many orderings can we have? Okay, so I put person one in seat one. Let's say I put person 8 in seat one. Okay, so now that seat one, how many options could I have had to put a person into seat one? Well, I can actually have 12, right? Because there's 12 people, so I can select 12 people. But I took 8 and I put it there. So how many options was this one? It was 12. So 12. Now for the second one, how many options do I have? I don't have 12 anymore because we already used up that one person. I only have 11. So let's say I now take person 2 and put it in seat 2. Okay. So I had 11 options and I selected person 2 and I put that, there we go. So we had 12 and then we had 11. And now we have another seat number 3. How many options do we have? Well, now we have 9 or 10 because there's 10 people. So then I take person, which one did I not use? 6, maybe? Person 6 and put it in seat 3. Okay, well, and then we keep doing that until at the very end is going to be, okay, all right, we have one seat left, or it's seat number 10, it's the last seat, and we only have one person left. How many ways or how many selections can I do? Well, just one. Once you've locked everything else in, it's just one, and that's the times 1. Okay, so that's factorial right there when we're locking in each time. All right, let's look. I'm gonna have a sip of coffee for my throat again. Okay. Okay, so use this when you can choose option 1 for variable A, and that doesn't stop you from choosing option 1 for variable B. That's like saying variable A, right? Whatever we did. So like rate can be 1 through 12, and I select 1. That doesn't stop me from changing channels to also be number 1, right? These things don't conflict. So variable A has 12 options, variable B has 12 options, and no matter what I select for variable A, it doesn't impact what I can select for variable B. That means independent, right? Now, the other one is permutations. Okay. Okay, so like a combination lock. So that means like those locks that you have like 4 different digits and you can choose like 0 through 9, 0 through 9, 0 through 9, 0 through 9. So how many are going to be there? It's going to be you have 10 options here, you have 10 options here, you have 10 options here, and you have 10 options here. So it's 10 raised to the 1, 2, 3, 4, like that. And so that's the combination lock. And each of those don't conflict. You can choose 9999, right? Permutations. Use this when you arrange items and using one up. Like 12 people sitting. Hey! Okay, darn. This was all. People are going to say, like, oh, you just saw that example. Darn, it used the one that I said. And because I didn't look at it, right? I was looking up here. I didn't look at this one. But people are going to be like, "Oh yeah, you just saw the answer." And then pretend like you were just pretending that you, oh, darn. Okay, fine. Well, I already explained this one, so we don't need to read it. Factorials are for ordering. Exponents are for independent setting. Awesome. So oh, I want to get something to drink. I'm thirsty. but we have so many questions that we want to ask. Did I put? I hope I put this in my. Hold on. Let's. Okay. Why your punk wolf speaker likely has one or two channels by asking for 24. The hardware says. 但是你没有看到啊？我忘记，我做了那个。Where is it? 我做了那个 Python 的叫什么？啊，这儿 Ripple。他说就是24 ，OK。But it says 24 when we do the ripple. So, man. But okay, we need to go look at this, right? Because we spent so much time doing that. Okay. We are going to come back to all of this, but right now I do kind of want to do a little bit of development. Okay, so let's come back. I think it gave me such little information because I asked so many questions. But let's see where we are. Where's it? Here. Okay. Now I'm trying to focus on how to actually solve this question here, period. When I do that script, which you told me to run, I see that it is 24. So I'm wondering why I need to change my channels to either 1 or 2, period. And how can I actually troubleshoot this, period? Because if the firmware is on the microcontroller in the speaker, I might not have access to that code, period. Okay, so I'm gonna open up Safari and I'm going to do, what are we gonna do? Let's see, where's the part number for it? Let's see, is this the part number? P1 U4. I don't know if this is a part number. USB speaker. Okay, data sheet. Okay, sure. What is this? Constant current LED. No, this is not. I don't really want to go and download random stuff though on my computer.我操！我真的不知道这个 part number. What was it called? Punk Wolf. Okay. Data sheet. Okay. Nuclear Regulatory Commission. Okay. Okay, so I don't think that they have a data sheet. Let's just close out of this. Whatever. I searched online and I don't really see a data sheet for this device, period. And the instruction manuals don't have any technical information, period. Let's just do this. And again, we're going to return up to here. We need to remember that, okay? But I do want to, I want a little bit of a success, okay? Like I want a little bit of development. We need to get back into that. And put that into the channels in your script. You have channels here. Oh, device index. Is that what I was trying to do? Hey. Yeah. I am not doing good now, am I? We do not want channels to be 24. I believe channels was 1. We want this weird, like, input devices to be 24. Okay. And now we want to run Python 3. Hello, can you hear me? Hello, can you hear me? Okay. Kind of good news, comma, I did not get a crash, but it doesn't seem to really be working and it constantly has listening and I'm not able to exit the program, period. After changing the channels and index to the correct thing, comma. Okay. So what else is it saying that we need to do? Y20. Okay, that's fine. That's nothing. One more trick. Since you mentioned wanting to save time, here's an alias to help you check your audio status instantly. Add this to your so it is the bash rc. Okay, alias mic check is we cat this. Okay, awesome. So we'll do that later. And doesn't immediately throw an OS error means the handshake between Python and ALSA kernel driver. Once again, see, this is, I go back and forth about the importance of digging deep into something. And that at the maybe midway through this video, I was thinking like, oh, am I going too deep into it? Am I going too down into the hardware kind of thing? Like maybe I should stay higher up, right? But then we come back to here and it's like, okay, well, the fact that it says listening and doesn't immediately throw an OS error means that the handshake between the Python and the ALS kernel driver and the USB host controller was successful. Okay, so now we understand a little bit more about what that actually means and what that implies and then how to move forward and fix the problem. If we didn't go and dive into this, we would be like, well, I don't know what that means. Like, it doesn't mean anything to me. And then we would just be trying random things, which I don't like doing my development I've seen a lot of people that they will just try one thing and then try another thing and try another thing, try another thing, and then this one works and then good. Good. Me, I used to develop that way, right? But it's very unsatisfying. The way that I enjoy doing things is understanding something fully and then one-shotting it. I know exactly what's going because once you understand it, the answer becomes obvious. It's like, oh yeah, of course I need to do it this way. And then you just do it, right? Um and then you don't guess the second time because the problem that I was coming into in the past is that I developed that way. I would change one thing, change another thing, change. Oh, this combination worked. Great. Oh, well, we want you to change something. Well, let me go back and do every single combination again because this one thing changed and I don't know what I'm doing. Terrible. But if you really understand what you're doing, first off, you take the time, you understand what you're doing, then you do it one time, you get it correct. Someone says, like, oh, well, we want something changed. Okay, no problem. I just change it. And then I know how everything else needs to be changed, and then it's good. So plus I get like enjoyment from actually like from understanding how things actually works. I really enjoy that feeling. So it's good on every single aspect. The reason you can't exit and nothing seems to be happening is likely because a blocking call issue combined with how terminal signals are being handled on the Jetson. In your code, you have this is a blocking call. Open a new SSH window. Keep the stuck one open for a second. And then grab. Okay, I see. I see what they want me to do. So, a Control Command T. Does that? I think that works on Linux. I don't know. Okay, whatever. New window. No, not TikTok. What do I want? SSH. Jetson. .local. Oh man, what is the SSH command? Okay, well, do you know what we're gonna do? We're gonna force close it. Because I can't remember the command. So there we go. That was probably not. Okay, so it'll be done now. Hopefully I didn't mess anything up on my Jetson, but okay. Terminate. Just go. Just go. Timothy at Jetson.local. Okay, fine. That was it. So it's username and then Jetson and .local. Oh my gosh. Right now I feel like there's so much going on. I need to remember to go back up to here and read all of this. We have so much to look into there. I know that we're gonna have more questions there. I'm trying to actually do my development, but that's kind of not working right now. Jetson. Okay. Now we also want to do those aliases. Okay. And I wanted AI. Is it directory? Yeah. Oh, okay. There we go. See? I didn't need to do ls. Okay. So I don't want to run this code, obviously. Okay. How to troubleshoot without a datasheet. Since we don't have a manual, we use proc file system, the live window, into the kernel's brain. Run this command while the speaker is plugged in. Okay, I'm just gonna run it. Whatever. We'll see what happens. No such file. Okay. No, I'm using card 2 because here showed USB device on card 2. I do want to recheck that because I just power cycled it, so possibly the device is enumerated differently. So what? A record minus L here, and what do we have? Device 19. Okay, so wait, where's card? Okay, so card 2. Was this device 19 last time? I can't remember. That's a good thing about recording my vid. Man, I should have changed. I am not the smartest character, am I? I should have plugged in my Apple charger while my Nvidia. I had just unplugged my Nvidia. Oh, okay, it'll fit this way. Here we go. Here we go. Okay, come on now. Okay. Okay, here we go. Here we go. Here we go. I don't want my device to run out of battery while I am filming. There we go. Okay, cool. D-Link. What to look for in the output? You will see a section called capture. No, we do not see a section called capture. Okay. All of that. What to look for here. Here. What is this? Based on your scan, here's how you should edit your file. Start with 1. If it fails, try 2. Never 24. Okay, fine, fine. Or we could do this, the standard USB rate. We can convert for whisper later. Okay. And then this is where 24 belongs. Awesome. Concept check Y24. When you ran Python loop, it gave you this. In the world of computer architecture, an index is just a pointer to a position in an array, okay? Pi audio device here, device 24. Now we're device 19, right? I power cycled my device, my Jetson, Nvidia Nano, and ran these commands, period. I now see that it is saying device 19, period. So this would indicate to me that the device actually changes based off of the enumerations, period. When and where does the operating system actually go through all of these things and assign values to everything? Question mark. If this is unstable, does that mean that my code needs to take into consideration that each time the system starts up, devices are actually going to be different locations? Question mark. All right. And then I felt like I had another question in there, but I forgot what I was about to ask. Okay. And to continue troubleshooting. Okay, actually no. All right, what I'm gonna do is I'm gonna go like this, and I'm gonna have this as question number 2. Okay, and then this one is going to be the troubleshooting one. Yeah. I was unsuccessful in running that cat command which you suggested I run because it seems to not exist. Period. Okay, so now what we're going to do is we are going to come way back up here so we don't forget this. This is the one that I skipped, right? Yeah. Okay. Can we drag you down a little bit? No? Okay, fine. I'm going to take a sip of coffee. Hold up a second. Okay. This is a dense and insightful set of questions. Okay. Number one and number two, memory, swap, and monitoring. You are correct to be cautious about swap on an SD card. The concern. The SD card has limited write cycles. Swap memory involves constantly writing, which can kill an SD card quickly. However, without swap, the Orin Nano, which has limited RAM, will hit an out of memory state and freeze. Okay. The kernel's networking stack, while it tries to kill a process to save itself. Okay, fine. Freeze the kernel's networking. Fine. Good. Solution. You can create a temporary swap file now when you get your NVMe, which, again, we actually do have, right? I wasn't planning on putting it in today, but maybe we need to put it in. You will simply delete that file and create a new one on the SSD. It won't make the transition harder. It's just a file you can delete later. Okay, fine. I feel like now we have another thing that we need to do. We have actually that's two new things that we need to do. And we still haven't even gotten this working. And now we need to create a swap file and we need to also eventually transition. Okay, so this is 2. Let's do 3. Can you show me the steps for how I would create a swap file? Question mark. All right, so htop, if you don't have it, install it. Do I have htop? Does it need sudo? Not found. Okay, so I don't have it. I don't want to install it, honestly. I don't want to. Can I do top? Right? Yeah. Okay. I can do top. That's fine. Okay. Awesome. So, here, system on chip, microcontroller versus silicon logic. So, system on chip is like a city. It's a microcontroller, and a microcontroller is like a single house. Okay. So, a microcontroller contains the CPU, a tiny bit of RAM, and basic peripherals like the GPIO, general purpose input output pins, and I2C, which I2C is a communication protocol. So you use the clock and data lines and you can like communicate on a bus to a whole bunch of peripheral devices. All-in-one die meaning the actual like chip. Okay. Designed for simple low power tasks. SoC, system on chip, is Orin Nano, contains a high performance CPU. So it has the CPU, which is ARM architecture, okay? A massive GPU, which is Nvidia Ampere. So that's the GPU. Oh, so it's within the exact same chip? A memory controller and specialized IP blocks like this. What is IP? Internet Protocol? IP blocks. Okay. 4. When you were talking about the system on chip, you mentioned that there is a CPU, comma, a GPU, comma, a memory controller, comma, specialized IP blocks, like the XHCI USB host controller, period. This means that it is within the same single chip which I see on my board. Is that correct? Question mark. So when I look at the PCB, I see a whole bunch of components, and one of the components has all of those things together in one single chip. Period. Again, why does it not do the ending period? That's annoying. 5. What is a memory controller? Question mark. And what did you mean by specialized IP blocks? Question mark. Does IP stand for Internet Protocol? Question mark. And what would an IP block actually look like? Question mark. Okay, fine. I like how I do this like every time I write something, because I write something, when I'm writing these prompts, part of the thing is like you don't really know what the question you're asking, because that's literally why you're asking the question, is because you don't know what you're doing. And so it's always very vague, and then I try to expand on things. So that's why I'm always like, I don't know, I think I got it. I think I asked a reasonable question, but I don't know. Maybe I didn't. Okay. How it's built, the electrical engineering perspective. You're remembering digital logic correctly. Engineers write Verilog or VHDL. VH design logic. Okay, hold up. Where is? I'm gonna open you up again. VHDL. Hardware description language. Yes. But what does it mean? Like, what is the acronym? Oh, I saw something that said, what did it stand for? History. Okay, come on now. Hardware description. Okay. HDL, but there's a V there. Very high speed integrated circuit. I've never heard VHSIC. I've never heard of that. Hardware description language, but where does the V come from? Whatever. Again, rabbit holes. Sometimes rabbit holes are very justified. Like, as I just said, oh, down here. Then I go all the way down here. Oh, down here, look, we went down these rabbit holes of ALSA kernel driver and USB host controller, right? And that really let us, now we understand what this means. Okay, that was a rabbit hole, and it was a very productive one, because we were doing something to understand the concepts around the project that we're working on. Going down a rabbit hole about what